Today we will go over section 6.3, which is multiplication of a vector by a scalar. Now, we learned how to add vectors. Now we will learn how to multiply these vectors. We will multiply it by the number k, which is a constant. However, it will produce a new vector when we multiply. There are a few situations we need to learn about before diving into problems. When multiplying, if my k is positive, like mentioned over here, meaning bigger than 0, direction won't change. However, depending on the value of k, your magnitude will lengthen or shorten. For example, if my k value is between 0 and 1, it will shorten. Why? Imagine multiplying your vector by 1/2. That is half of what you have. Therefore, the magnitude will decrease by half. However, if the value of k is bigger than 1, then it will lengthen, it will get bigger. So if you multiply it by 2, it will double in the size. Second situation is when your k value is negative. In this case, unlike the first case, your direction will change. And as stated before, if your value is between 0 and -1 now, it will shorten the magnitude 2. If bigger than 1, it will increase the magnitude. It doesn't matter if it's, technically this is not a big value. When you go to negatives, it just gets smaller, smaller, smaller. But if you multiply by -2 in the opposite direction, it will lengthen, is what we mean. So you might be asking, what about the cases where my k value equals 0 and -1? If multiplied by 0, I will obtain the 0 vector. If multiplied by -1, it only changes direction and magnitude stays the same. Now there's this thing called collinear vectors, and they occur when there are two vectors and they are parallel to each other, or they lie on the same straight line. These lines can be translated so they lie in the same straight line, such as if I had two vectors, let's say, one like this and another one like this, I can move this onto this vector and it will be on top of each other. For example, all lines over here are collinear. The magnitude of it doesn't matter. It doesn't mean identical. Collinear and identical are not the same things, but they're collinear and they're two different things. So it just needs to be parallel and they need to be lying on the same straight line. Three collinear vectors a, b, and c are such that a equals 2/3b and a equals 1/2c. Determine integer values for m and n such that mc plus nb equals 0 vector. How many values are possible for m and n to make this statement true? Now, the equation given to us is mc plus nb, right? What I don't have is the c value as well as the b value. However, what they gave us over here is in terms of a, I have the b, and in terms of a, I have the c. To find the values for c and b, I can just leave b alone as well as the c alone and plug it right back in here. So all I'm going to do is take the first one, which is a equals 2/3b, and I will leave the b alone. I'll do that by multiplying each side by 3 first, so I got rid of that 3. So now I'm left with 2b equaling to 3a. Now I'm going to divide each side by 2 to get b vector equaling to 3/2a. So that's one. Now I'm going to do the same thing for the c, which is I have a equaling to 1/2c. I can multiply each side by 2 to get rid of this. So now for c, I have 2a. All I need to do now is plug them in here. So put the values together and equal it to 0. So that means having 3/2a. Let's start with c first because that comes for just in case. So 2a plus 3/2b, 2a, sorry. So this was my c value, this was my b value, and I equal them to 0. From here, I can multiply to leave this alone. I can multiply each side by 2. So if I do that, I'll get 4a plus 6a equaling to 0. Not the 6a, so that's 3 because we canceled this one out. So I have 3a left. Now I can send that 3 to the other side as negative. So I will have 4a equaling to negative 3a. And I can just cancel the a's out since they are the same thing. So I will get my values for m and n. So remember, this represented my c. So for my m value, I would get 4. And for my b value, which represented over here, the n value would be negative 3. Now this is one possible answer. When it says how many values are possible for m and n, because it's not asking what is m and n, it's asking how many values are possible. All you need to do is, this is one possibility. However, I can also multiply both of these by 2 to get 8 and negative 6, because it will carry the same thing when you divide it up. So you can also multiply this again, and you would get 16 and then negative 12, whatever. It just goes on like that. So as for the values, number of values, I actually have infinitely many possible answers. Now for the second part, it wants me to determine the integer values for d, e, and f, right? So for these values, they also say, are these values unique? They're asking us. So I'm going to do the same thing. I'm just going to write everything in terms of a, right? So right now what I have is dA, and I have EB, which I found what is B in terms of A, right? So I can just plug that in, saying E and 3 over 2A. Or we don't need to write the E because we replace it by the constant. And I do plus, and whatever C is replaced by, so that's 2A. And this will equal to 0. From here, I can actually cancel out the A's, right, to get, now I will be left with D plus, I also need to put the E. It's not really being replaced by the constant because that replaces the B. So I have E over here, which I can say 3 over 2E. And I will also have F over here, which gives me 2F equaling to 0. So now that I have this, your solution varies. You can have multiple solutions in this one. So what I'll do is I'll plug in 2 for my D value. If I plug in 2 as D value, then the rest is I have 3 over 2E plus 2F equaling to 0. In order to make this statement true, saying it actually equals to 0, what I can say is make my EF, let's say negative 1. If I do that, I'll have 2 minus 2, which equals 0. And I can make my E value equal to 0, so it doesn't balance it out. Like if I put 1 for this, then it equals to 1. That's not what I want. So I'm putting that equal to 0. So as the values, I have one set of values. I have D equaling to 2. I have E equaling to 0. And I have F equaling to negative 1. So those would be my values. But are these values unique? No, they are not unique. Now, unit vector is a vector which has a magnitude of 1. For example, if I have a coordinate 1 and 3, and I try to calculate the magnitude, I would get root 10. Then it doesn't represent the unit vector because it does not equal to 1. However, let's say my coordinates are 1 over root 2. Taking the magnitude of this will give me a value of 1. In order to find the unit vector with a coordinate such as 1, 3, like the one that didn't work out, we multiply the vector by 1 over the absolute value of the vector. Just an example, it would be here. If my vector's magnitude is 3, all I need to do is multiply that with the vector x and put it as 1 over 3. To verify, we can put the magnitude into my vector x and I will get the value 1. Unit vector is the base of the vector and it's used to separate the magnitude from the direction, and this would be helpful in the future in calculations. So to get used to unit vector problems, given that the magnitude of u equals 4 and magnitude of v equals 5, and the angle between u and v is 120 degrees, determine the unit vector in the same direction as u plus v. So just to draw it out, let's say this is my u and this is my v, and I know in between I have 120 degrees, right? I can use the triangle law for this. If I add these vectors, let's say this goes like this, right? And that's my u that's added. So I'm going to erase this u not to confuse you guys. And then my main vector will start from here and go like that, and this would represent u plus v. Now, if you were to draw this on a better paper with squares, what you would end up getting is actually this 120 degrees where the u plus v cuts is represented by 90 degrees over here. So this should be 90 degrees. And from here, the way it cuts over here, you get a 30 degrees. This is gone by the same thing. This, you can also draw the same thing over here, the other way around. So if my u was here, this is my u, and then my v came the same way, it cuts also 90 degrees over here. Since the whole thing is 120, that's how I got the 30 degrees. So what I have left for the other degree is 60 degrees, and that's the degree I'm going to use to find. By the way, this is u, not to confuse you guys. Yeah. So I'm going to use the cosine law like before. So this is my cosine law. What I'm going to do is I'm going to plug in the values given to me. The magnitude of u is given to me as 4, so that's 4 squared. Magnitude of v given to me is 5. And then I keep my constant to the value of u is 4, value of v is 5, and the degree in between for me is 60 degrees. Now when you plug this into your calculator, you're going to get a value of 21. But remember, this is squared. I'm trying to get the magnitude just as it is, not squared. So I'm going to root both sides to get a value for u plus v, vectors being root 21. Now that I have my value, it wants me to determine the unit vector. Like in the previous slide, how we do that is we take this magnitude, we multiply it by 1 over the absolute value of this, which would still come up to root 21. And then we multiply it by the original one, which is u, and then plus v. And these are two separate things. And if we want, we can separate this into brackets, or we can leave it as it is, doesn't matter. If we do separate it, distribute it, we're going to get 1 over 21, root 21 u plus 1 over root 21 v. So that's it. The vectors x and y are unit vectors, vectors with magnitude 1, that make an angle of 30 degrees with each other. First, they want us to calculate the value of 2x minus y, and then they want us to determine the direction of 2x minus y. Now, when I draw x and y as unit vectors, this is what I get. And because they are unit vectors, this means the magnitude of y will equal to 1. So now that they want 2x and a minus y, that means multiplying this by negative 1 and multiplying the x value, which has the same magnitude 1, by 2. So I'll redraw this with what's given to me. So because x is multiplied by 2, we double the length, and because y has a negative now, it just changes its direction, so we flip it. So I also can figure out what's the degree between them because it didn't really change. So over here, if I didn't change y, it would be something like this, where I still have this 30 degree between them. However, remember the z rule, it means whenever you have something like this, degree over here will equal to degree over here. So you can also find it like that, but the degree just doesn't change. So from here, I can find my resultant, which would be this. So this is 2x minus y. Now, as for part A, I want you guys to do it because it's the exact same procedure that we did before. Previously, you're going to use the cosine law. Okay, just use the cosine law and you would get the value of 1.24 for the value 2x minus y. And as for B, determine the direction of 2x minus y. That's the different part. That's the part that we didn't see before. Now over here, when it says determine the direction, you might be saying, oh well, I already have 3 degrees, but that's not the direction. If you put it into x and y plane like this, what we have the vector, if I do that, and this is my y plane and this is my x, this is where I have it. I have my vector in the 4th quadrant, right? So over here, what I need to find is the simplest one is right over here. I need to find the degree between the 2x and my resultant vector. Now, since I don't know my values, I can just use sine law. It's the easiest one. So sine law, what we do is you take sine of the unknown angle that I'm trying to find, and I need to see which magnitude it's looking at. That degree represents minus y, and so then I put the magnitude of minus y over there. And then we do this equals to the other angle right over here, so that equals to sine 30 over the vector it's looking at, so that would be 2x minus y. From here, I know the magnitude of this, I know the magnitude of this, and this just needs to be plugged in, so I can leave sine the degree I'm trying to find alone. So when I do that, all I need to do is plug those in. So I'll start with plugging the numbers in. For minus y, that's just going to become 1 because it's a unit vector, and that would equal to sine 30 over 1.24, which we found before. And if I leave sine degree alone and send that sine to the other side, because I'm trying to find the degree, I would get sine -1 sine 30 inside all over 1.24. And when you plug that into your calculator, you would get a value of 23.8 degrees. If you have any problems that you would like me to elaborate in this video, as well as any problems that we couldn't solve in this video also, you can always go to our website and go to the forum section to put a problem, and we will give you the solution to it.